The pressurization system for the Boeing 777 is similar to those of other Boeing airplanes. The system consists of two air supply cabin pressure controllers, a remote pressure sensor, two positive pressure relief valves, four negative pressure relief vents, and a forward and aft outflow valve. The Air Supply Cabin Pressure Controllers, or ASCPCs, send and receive data necessary to control the pressurization system. The left ASCPC is considered the master controller. The right ASCPC automatically assumes control should the left ASCPC fail. The left ASCPC receives data such as valve position from the left channel of the forward and aft outflow valves. The right ASCPC receives right channel data from both outflow valves. Each ASCPC has the ability to self-test and report faults within the cabin pressure control system. Cabin pressure data is sent to AIMS from sensors in the ASCCs and from the remote pressure sensor through ELMS. If valid ASCPC cabin pressure is not available, AIMS uses cabin pressure from the remote pressure sensor. Data to and from the pressurization panel is provided from the 629 bus. Outflow valves can be manually operated from the pressurization panel. Two outflow valves are used to regulate cabin pressurization. Normally, 20% of the air is exhausted through the forward outflow valve and 80% through the aft outflow valve. This improves smoke removal and ventilation. Two positive pressure relief valves prevent overpressure conditions. Each valve incorporates dual sensing for two levels of pressure relief. Should an overpressure condition occur, the valves open to relieve the pressure. The cabin differential pressure indication changes color from white to either amber or red if an overpressure condition occurs. There are four negative pressure relief vents, two on each side of the forward fuselage. The relief vents prevent a negative pressure condition which could occur if the airplane descends at a rate too fast for the cabin pressure controller. There is no crew alerting for this condition. Controls for the pressurization system are located on the overhead panel. These switches control outflow valves and are normally left in auto. Select Auto. With the forward and aft outflow valve switches in auto, the manual lights extinguish. The ICAS caution message Cabin Altitude Auto is removed, and the letter M, which indicates the outflow valve is in manual mode, is no longer displayed. The landing altitude select is normally left in the auto position. The manual position is used for certain conditions and will be explained later in this lesson. For now, push the landing altitude selector in to select auto. When the auto position is selected, the ICAS advisory message landing altitude is no longer displayed. And MAN, which indicates that the landing altitude selector is in manual mode, is replaced with auto. The pressurization system has several different modes of operation. Let's look at a typical flight profile as we discuss the various pressurization modes. During airplane power-up, the ASCPCs perform a self-test of the system and apply power to fully open both outflow valves. After a short period of time, the system transitions to the ground mode, where the controllers perform another series of tests on each outflow valve. Before the takeoff roll, the pressurization controllers calculate a pressurization schedule based on information received from the FMC and other systems. This information includes airplane cruise altitude, time to climb, where the top of descent point is located, time to descend, landing altitude, and ambient and cabin pressure. The ASCPCs continuously monitor this data and update the pressurization schedule throughout the flight. During the takeoff roll, the controller starts the pressurization process. The outflow valves begin to close. This pre-pressurization process minimizes pressure transients during liftoff. After the airplane leaves the ground, the system transitions to the flight mode. The flight mode is divided into three phases: climb, cruise, and descent. During the climb phase, the controllers command an average cabin rate of climb based on the takeoff field elevation, the planned cruise altitude, and the airplane time to climb. The airplane transitions to cruise phase when the time for climb value reaches 0. The maximum cruise altitude is 43,100 feet. The maximum cabin altitude for cruise is 8,000 feet. And the maximum differential pressure is 9.4 psi. The cabin altitude remains constant during cruise. If an unplanned step climb is initiated, the pressurization system transitions to the climb mode. The system returns to the cruise mode after the airplane reaches the new altitude, or is level for 1 minute with VNAV not engaged. The system transitions to the descent mode when the airplane initiates an unplanned descent to a new cruise altitude. It returns to the cruise mode when the airplane reaches the new altitude, or is level for 1 minute with VNAV not engaged. For a typical descent to an airport with a landing field elevation lower than the cabin cruise altitude, cabin descent begins at the FMC top of descent point. To calculate the descent profile, the ASCPCs consider landing field elevation, time to descend, and barometric corrections. The target descent altitude for the cabin is set at 190 feet below airport field elevation. This design is for structural reasons and ensures that the airplane lands somewhat pressurized. At touchdown, the ASCPCs open the outflow valves slowly at first and then at a greater rate until the airplane is fully depressurized. After the outflow valves are fully open, the system transitions to the ground mode. Now let's go back and take a look at conditions which change the normal pressurization schedule. The ASCPCs account for planned holds and level-offs when calculating the normal pressurization schedule. If a hold or level-off is included in the VNAV profile, the cabin continues to climb during the hold or level-off. For unplanned holds or level-offs, or any time VNAV is disengaged, the ASCPCs revert to an internal pressurization schedule for control. If the airplane levels off and remains at a constant ambient pressure, the cabin altitude levels off and remains at a constant altitude. When VNAV is re-engaged, the ASCPCs return to the normal pressurization schedule. If the takeoff field elevation is higher than 8,000 feet, the cabin descends to the target altitude while the airplane is climbing. The cabin rate of descent is limited to 300 feet per minute unless the maximum pressure differential is in danger of excess. If the destination airport elevation is greater than 8,000 feet, the cabin altitude climbs to 8,000 feet after takeoff and remains there during cruise. The ASCPCs calculate where the cabin altitude should start climbing to the destination airport elevation. The point is normally at the FMC top of descent point. The landing altitude used by the ASCPCs depends upon the distance of the airplane from the departure airport. If the distance from the departure airport is less than 400 miles, or less than halfway along the route, the ASCPCs use the departure airport's landing altitude to the nearest 100 feet. During a return to the departure airport, crew action is not required when dealing with the pressurization system. After the airplane passes the halfway point or travels more than 400 miles, the landing altitude changes to the destination airport's elevation to the nearest 100 feet. If a diversion is required, the ASCPCs need updated information to calculate the pressurization schedule. You may enter the new destination airport into the FMC, or you may manually select the landing altitude, as you will see in a moment. There are non-normal ICAS messages associated with control of the cabin altitude, outflow valves, and control of landing altitude. If the cabin altitude climbs above 8,500 feet, the pressurization information displays on ICAS and the cabin altitude display turns amber. If the cabin altitude climbs above 10,000 feet, the cabin altitude display turns red and the ICAS warning message cabin altitude displays. If the cabin altitude cannot be controlled, descend to a lower safe altitude. The ICAS advisory message outflow valve aft or outflow valve forward displays when automatic control of the outflow valve has failed or the respective outflow valve switch is in manual. In either case, the pressurization information pops up on ICAS with the affected outflow valve displayed in amber. The affected outflow valve can be controlled manually by selecting Manual on the outflow valve switch. Select Manual. When the outflow valve is in manual, MAN appears in the outflow valve switch. The outflow valve changes color back to white and the letter M appears on the outflow valve indication. The outflow valve can now be opened or closed by toggling the respective outflow valve manual switch. Close the aft outflow valve. As you can see, closing the aft outflow valve caused the forward outflow valve to open. In our example, the forward outflow valve is now used to control the pressurization system. Further crew action is not necessary. The ICAS caution message Cabin Altitude Auto displays when automatic control of both outflow valves fails. The message may also display if both ASCPCs fail or if both outflow valve switches are in manual. Because the automatic system failed, cabin pressurization must be controlled manually. Select MAN for both the forward and aft outflow valves. As you saw in the previous non-normal, when the outflow valves are in manual, MAN is displayed in the outflow valve switch and the letter M appears in amber on the outflow valve display. You adjust the cabin altitude by toggling either outflow valve open or closed. Open the forward outflow valve to set the cabin altitude to 6,000 feet. As the cabin altitude approaches the target altitude, the outflow valve is closed a small amount to maintain a constant cabin altitude. Close the forward outflow valve a small amount. The ICAS advisory message, Landing Altitude, displays if the landing altitude information from the FMC is not available, or if the landing altitude selector is in manual. For this example, the message is displayed because the FMC data is not available. When the message displays, the pressurization information pops up with the landing altitude value and auto-blanked. Pressure reference now comes from the captain's altimeter. Pull the landing altitude selector to manually control the landing altitude. When the landing altitude selector is in manual, 0 feet is the landing altitude value and man appears in amber. The landing altitude selector has two positions to set the landing altitude. The landing altitude display changes in 100-foot increments at the first detent. The second detent increases or decreases the landing altitude in 500-foot increments. The selector is spring-loaded to the 12 o'clock position. Use the lower rate to set the landing altitude to 500 feet. Now use the higher rate to set the landing altitude to 5,500 feet. Once the landing altitude is set, further crew action is not necessary.